In the Silicon Lab, we take a fully processed device and we analyse that layer by layer down to the transistor level. Transistors are the building blocks of the semiconductor industry.
A lot of the work that I've done previous to the Silicon Lab has been higher level, either code or logic. But at the silicon level, you are at the lowest level. There is no logic or any sort of thing below that besides the physics itself.
Hardware hacking continues to evolve, and in turn, the developers, the creators of these devices, have been learning and making them stronger, more secure.
The semiconductor space really is an exciting frontier in security because it is the ultimate limit of low-level reverse engineering. As a defender, you need to focus on every single way that someone can compromise a system, and our goal as a research-driven security services firm is to get out ahead of these emerging threats and develop testing techniques that can work in these unexplored areas.
Going down to the silicon is the last bastion of where the secrets are today.
The Silicon Lab is set up so that we can reverse engineer computer chips at the lowest level, the silicon level, so that if there's any sort of secret or hard-coded things that you normally would not be able to access on a computer device, we would be able to access it with the equipment here.
Here in the lab, our mission is to help identify the vulnerabilities, help identify the methodologies that attackers may compromise the device today, into the future, and guide our customers into designing more secure versions of the devices, of the silicon layer, and the mechanisms around securing the device in its entirety.
There's a lot of ways that fakes can end up in supply chains. One of the most common is if you have a part that is in short supply, there are going to be unscrupulous resellers who will pick up anything that looks vaguely like it, same number of pins, same package size, and so on, and just grind off the original laser markings and remark it as a legitimate chip.
The supply chain now represents a critical vector for attack. We've seen counterfeit devices, compromised devices enter that supply chain. And so one of the things we do and help our customers at IOActive is to identify compromises of that supply chain, integrity of the devices, and provide advice on how to secure that supply chain overall.
We take our transistor level analysis and combine that with 25 years of experience that IOActive has in the security industry, and we offer something truly unique.
In the 1950s, a famous bank robber, when asked why they robbed banks, his answer was, that's where the money is. Today, why would an adversary target the silicon layer? Because that's where the secrets are.